Hello everyone. In this session, we are going to discuss about the map-reduced flow, and we will try to elaborate this flow with the help of diagram. So let's draw the diagram. You have an input file, or we can say we have an input files. Then this input file will be having some kind of input format. This input file is divided into the different input splits as we discussed in the last section. So now we have input splits. So I'm just trying to make it the input split in number of times, like input split 1, input split 2, and input split 3. So I'm just trying to connect with this arrow. That means now the input file is broken down into the different input splits, and it will be more than 3. Definitely it will be having a number, depends upon the data. Now this input file will be read by the record reader. The record reader is going to read the data from the input splits. These are the record readers. Now after that, we are going to discuss each and every component in detail. So just before that, just let's draw the diagram first. Then we have a mapper. Then we have a partitioner. Now after that partitioner, we are writing in a different color with a sufficient short. Just just due to the paucity of space, I am using this diagram a little closer. So this is your sufficient short. So now after the sufficient short, we have a reducer phase. Let's say I'm just making only two reducer this time. So now the data from the sufficient short will go to the reducer as we discussed in the map reduce stages. Now after that we have a record reader, or sorry, not record reader, it's a record writer because record reader was for the reading. So now we have a record writer, and after that we have actually the content of the result. Actually we need to write in some to the output file. That means now we have some kind of output format just like an input format. So we have an output format, and in the end we can say that we have the output file, right? So now we are going to understand each and every component in detail. Few of the components we have already discussed, and just like in an input split. So let's start with the each and every component one by one. So now let's say data is there into the HDFS in the Hadoop distribution. So now we have data into the, let's say, HDFS. So now input file is having some kind of input format, and then this input format is actually the data is divided into your input splits. The input splits can be more than one. It will be definitely many input splits. After the input split, we have the data will be read by the record reader. So now first understand what exactly the input split is. We are going to discuss input split in very high level over here because the input split is completely a different topic I am going to discuss in the coming sessions. So now on the very high level, input split is actually your logical representation of data that is stored in the file blocks, right? And you can also say that this input split is actually a unit of work that contains a single map task, right? So what does it mean? That a single input split will be forwarded to the map task, or you can say that single map task will process the data contained in a single input split. So one input split represents the data for the map task. Now let's discuss about the what is actually a record reader. So now actually record reader reads the data from the input split. The major functionality of the record reader is a read the data from the input split, and this data it is going to read over the different iteration. So now let's write record reader read data from input split, and this reading will be on the different iteration. That means it will iterate over the records. So all the record it will iterate for this. This record reader provides each record in the form of key value pair. That means this record reader will provide the each and every record from the data, or even we can say each and every record from the input split, because input split can contain number of records. So it provide record reader provide each record in the form of key value, because the important point in the map is it is a key value. That means it provides each record in the form of key value pair to mappers. Now it is the responsibility of the record reader responsible for determining what data to feed into the map function, because the record reader will take the data from the input split, read each and every record, iterate over the record, and then it will make the key value pair, and then it provides the data to actually the map function. Okay, now that means it is the responsibility of the map reducers just to check what kind of data we need to it need to feed into the map function. And in this, like each task has a single record reader, and which is responsible for reading the data from the input split. From input split. Now, the important thing is like this record reader is responsible, or you can say record reader actually communicate. It actually communicate with the input split until file reading completes. It means that once the record reader trying to read the data from the input split, and then it will read each and every record, and then it will do this communication with the input split until all the reading completes. Okay, so now after that in the diagram we have a partitioner. The partitioner, we are going to discuss this partitioner in completely detail in the coming session, because this is a very important topic. Let's understand on a very high level. The partitioner actually control the partitioning. So it actually controls the partitioning. So partitioning is actually the divide the data based on the key. Okay. So now that means control the partitioning means that it actually do the partitioning of key. Partitioning of key of your intermediate data. And this intermediate data is actually your mapper output. This is the important thing you need to understand. Now, While doing the partitioning, this partitioner actually uses the hash function if we use a default partition. It uses a hash function if you use a default partitioner, or otherwise we can also create our own custom partitioner based on our own requirement. And in the coming session we are going to see the partitioner, and in that we will discuss about more about the custom partitioner, how we can create the custom partition. Now this hash function is used for this partitioner, and this hash function is used to what, derive the actual partitions, to derive the partition. So partition is actually your segregations of the data based on the key, and this partition will help us to process the data, and we keep all the partitions based on some keys of data, some logic of the partition, just like a hash function. And after that, this partitioner actually redirect the mapper output, the redirect the mapper output to the reducer, right? And this will do on the basis of, or based on the key. I'm just writing based on the key, right? So this is a very high level idea about the partitioner. And the last component left was a record reader. The record reader is very simple one, as the name suggests that it is going to writes the reducer output to the destination files. And when I say destination file, I mean to say data source. The data source can be your again HDFS, or it can be any visualization tool, or it can be some cloud S3, whatever it is. So it is a different data set. So this is all about the different components of this. So now let's move back to the diagram. Okay, now we are on the actually diagram of the MapReduce flow. Now you can see that in this diagram, first we have an input file. Based on the input files, we have input formats, and then data is chunked into the input splits. We have three input splits in this diagram, and then the record reader actually reads the data from the input splits, and then this pass add some values, add some key values to the data, and keep on reading the records from input split, and it communicate with the input split until all the records are over. And then after it pass this intermediate data to as an input to the mapper, and then in the partitions happens. And after that shuffle and sort, we have a reducer. The data from the shuffle and sort we have already discussed in the last session. The data is intermediate data is passed to the reducer, and after that we have a record writer which actually uses the output format to write to the output files. And here we can say that these output files are the uh, different data sources. So this is all about the MapReduce flow. Now, in continuation with this session, let's see what are the different limitations of the MapReduce. Okay. So now let's see what are the different limitations of the MapReduce. Now, because if we compare with the latest technology like Spark, which is also a distributed processing system, then there are a lot of limitations of the MapReduce. But we are not keeping those comparison between the MapReduce and Spark. But we can understand that what are the different limitations are there in the MapReduce. Now, first limitation you can say that the MapReduce is having a issues, or having a problem with small file. So if you know what is an Hadoop, or you know what is an HDFS, even in HDFS also there is a limitation of the small file system. And just to overcome that, the creator of Hadoop, Doug Cutting, introduces the new file format called Avro. So this again, this and there is an issue with the small file system, and it is having a slow processing speed, because it is a batch processing and it takes lots of data. Then definitely it is a slow processing speed as compared to the new technologies also. And while doing the lab, or while performing some of the hands-on, I'm going to show you that how the processing speed is slow. And the MapReduce supports for batch processing only, And nowadays, now new frameworks are also supporting the real time. That means there is no real time data processing in the MapReduce. And once we run the program, it takes a lot of time. That means there is a latency because the batch processing system are not that much, but they do the processing in a chunk, a lot of data. So batch is, when I say batch, I mean to say that fire and forget. That means we say that okay, this is the data we need to process, and then we do nightly batch, weekly batches. So these kind of data we have. Now latency is again also a problem in the MapReduce. It takes a lot of time to use that, and because it is written in Java, it is quite easy, but the lot of boilerplate code is there, and because of that, it is not that much easy to use. That means we have lots of boilerplate code to remember, and it is not efficient for caching. So it does not support, it's not good or not efficient for caching. Or you can also say that it is not good for joining. That means if you want to join, and that means joining to large data set and with some complex conditions, then the MapReduce is not a suitable choice for doing those stuff. Next is, it is not the suitable for the interactive jobs. So when I say interactive, it is something like you have an SQL editor or SQL prompt. You just type a query, it will give you the result immediately. That is a more interactive. You read select star from this, insert something, that will immediately give that. So this kind of things, which is not not available in the MapReduce, that is, it is not suitable for the interactive kind of job, because this is a batch job. And apart from that, it is also not good for iterative job. So iterative job is basically used for the machine learning. So we use for machine learning, where we need to iterate the same kind of job multiple times, and this is very expensive due to huge space consumption. So this is not iterative job, is actually is very expensive due to huge space consumption. Right now, this the important thing is like the dependent task in this MapReduce we cannot parallelize. Basically, MapReduce is used to break the data, and then we can process it on the parallelly so that we can get the result fast. But the dependent task cannot be parallelized. Right? And it is also not good for the OLTP. So it is not good for OLTP, that is an online transaction processing. So it is not good for online transaction processing. And also there are a lot of n number of limitation, but we have to restrict somewhere. So just I will include one or two. It is actually a stateful operation. And if you remember that in Hadoop ecosystem, and functional programming of Python supports stateless operation, then if the operations are stateless, then it is definitely supporting the functional programming, and it is also supporting the Hadoop ecosystem, or you can say big data support for the big data operations, big data distribution, big data supports. So that means this is also a stateful operation. One more limitation I want to add: the task, actually this is also very very important. The task that requires global sync, okay, or you can say sharing of mutable data, for those kind of operations, this MapReduce is not a good choice. We can also add one more thing, like it is not good for delta, no delta iteration. No delta iteration means that, suppose if you have if you process something and you want to add more processing on the top of that, it is not supportable for that. So this is all about the few of the limitation we have for the MapReduce. Thank you very much.